Well, hello, Sky Protocol community. This is Gauthier, and I'm today with Fare. We are going to have that little short-term update. It's been a few months, and there are a lot of things that we need to talk about. So we thought that instead of delivering a um, fast, a speedy video, we would take the time to answer to all the questions that you guys had in the Sky Protocol community on Discord or on Twitter, and we can also, of course, show you what we've done so far. Fari, can you please first of all talk to us about the recent updates that we've delivered?
Hi. Yes, so we've delivered our two first updates from the Catalyst. So it's basically we wrote a first version of the smart contract and then made it fledged it out a bit. Meanwhile, we've been working on the Node software and we started writing prototyping it in Scheme. And lately, we've decided that the prototype is satisfactory, and now we want to move to something closer to production. And we could have stayed with Scheme, but for many reasons, we decided to try writing it in Haskell because for the main reason being we want to integrate with the Cardano ecosystem better, and it's all written in Haskell. So we find, sure, we could continue writing it in Scheme, but we want to reuse a lot of bits of Cardano, and it's easier to write it in Haskell. So that's what we're doing. And one key piece of Cardano that we want to use to anticipate one other question we had was what consensus are we going to use? We want to reuse Ouroboros as much as possible. We cannot use Ouroboros as is. There are small modifications we need to make, so we'll have to fork it and change how it works slightly. But mainly, we want to use the algorithm from Ouroboros. What change do we need? We will need changes such as, well, we don't work with the Cardano token, we want to work with the Sky token. Also, the Sky token is not defined by the chain under consensus, but it's defined by either what's on Cardano or what is on one of the consensus we have. And actually, we have plenty of chains per topic. So the whole point of our design is we divide the traffic into plenty of topics. So each topic is limited in throughput, but if you have basically no limit on the number of topics, then you can have a lot of throughput in parallel. So, but each topic will have its own consensus, but all these consensuses will be driven by the same token, the same proof of stake token. And so that's why we need to small changes to Ouroboros. So first use the Sky token for all those consensuses, whatever. What's the problem?
The
The
plural
proof
must be.
consensus. The proof of consensus in Latin it's consensus, but in English I don't know.
So the plural from consensus could be consensi. I don't know, whatever.
That's totally wrong.
The different
Okay.
types of consensus.
Yes, so we have each topic will have its own consensus. All these topics will share the same staking token for staking. And so that's one change. Another change is precisely that we have lots of topics. And the whole point of, once again, the DA is that these topics did not talk, not everyone needs to listen to all the topics, but everyone only needs to listen to the topics he cares about, which means that we need to have a gossip protocol that understands this notion of topic. And LiP2P is such a gossip protocol, but LiP2P does not exist for Cardano. And we want to use the gossip protocol of Cardano if possible, but then we need to modify it to be a bit more like LiP2P. So we'll see what we use for gossip protocol. That's a topic of active R&D right now. What topic aware gossip protocol we're going to use. And we just hired a third developer to work just on that. So we had, so far, two developers. We had Manuel who works on the contract in Plutus. We had Yaroslav who works on the node. So far it was in Scheme, now we're moving it to Haskell. And now we have Tanaka-san who is going to work on the gossip protocol, probably in Haskell. So right now we've decided to do it in Haskell. It's just a small chance that we'll go back to Scheme, but it's a small chance. Like it's let's say 95% chance that we're going to stick to Haskell. But it's possible that after some R&D, we decide that no, this is not the way to go. But I think this is the way to go, and that's a bet we're making now.
Question 4.
What I mean, it's still time to change if we need to change, but this is the direction we're heading towards.
All right. Question for our listeners, because some of them were asking, can you vulgarize what a gossip protocol is?
Gossip protocol. So the consensus is the thing that allows you to everyone to agree on what's the truth. Here is the state of the system. Here is this is the next block in the blockchain. This is the stuff that's been published in the DA. It's an agreement. But before you reach the agreement, you need to communicate your potential agreement or communicate the things you may or may not agree on. And because you need to communicate it before you agree on it, you need to have this communication layer that precedes the consensus layer. And this communication layer is called the gossip, because everyone is going to talk to everyone else to say, hey, have you seen this transaction? Or have you seen this thing? Have you seen this thing? Here's something you might be interested in. And so this is called the gossip protocol. And in the case of blockchain, traditionally, this gossip is everyone is interested in everything. So everyone, it's a flood protocol. Oh, here's all the information that everyone has, everyone shares with everyone. And that works well enough for the purpose of Bitcoin or Cardano. But then if you want to massively scale, if you want to do lots of things in parallel, you find that no, not everyone is interested in everything. I'm only interested in this and that topic. I'm interested in the main. Everyone needs to follow the main chain, for instance, and everyone wants then, okay, I'm going to follow the main chain and then this topic and that topic and not everything. The whole, if you had to follow everything, you couldn't scale. That's the whole problem with blockchain. Probably blockchains don't scale because everyone listens to everything. And the solution to that is, well, after all, not everyone is interested in everything. Everyone is interested just in a small part of the data. So let's keep 4 kilobytes per second for Cardano, another 4 kilobytes per second for the main chain of Sky, another, and each layer of topic that you're interested in adds 4 kilobytes per second of code, and not too much. And you don't want to overrun over something, overwhelm. You don't want to overwhelm your node with more data that it can process. Otherwise, you can only have one node in the world, in the entire world. You can run the thing. You're back to centralized. You're back to centralized design. The whole point of making it decentralized is that you want to have lots and lots of people who each care only about a small number of things. So that's the whole design of Sky Protocol and of DAs in general, but Sky Protocol in particular. And we want to parallelize things and make it so you only need to focus on part of the data. And this way, once again, the goal is that once everyone only needs to look at a small part of the data, then all the data can be made decentralized. Right now, it's very hard for the data to be decentralized because everyone has to look at everything, but when that's not the case, now we can have very large volumes. We could put all of Twitter or Facebook or whatever on the internet, and you don't need to read all of Facebook. You only need to read the feed of yourself and your friends, and that's not that much. So you could have all Facebook decentralized because not everyone wants to listen to everything.
Fascinating. And earlier you talked about the Sky token. So some people on Discord asked us, is there an explanation regarding the role of the Sky token? So it's a token that people are going to stake, but it's also a utility token. So because I told you guys on Discord that I would ask Fahre to explain that directly because he's so much better than me at explaining that, can you please do that for us?
Okay. So first and foremost, the Sky token is a staking token for the Sky protocol, which means that Sky protocol is an economic validation network like all blockchain networks, which means that the members of the network basically ensure that the network is doing the right thing. And how do we know that they're not lying? Because their economic incentive is to be truthful, or else they're either kicked out of the system or the system loses its value. So you can only partake in the system if you put a stake, if you drop money of the system in your in the system and say, hey, here's a $1 million worth of token, and I put basically my word. I put $1 million worth of my word on it, and if I lie, I will lose some or all of this $1 million worth of token. So my incentive is not to lie. So and the more tokens are put at stake, and the more effective is the feedback mechanism, the more you can trust the system. So if you can put $1 million, but there's no consequence to lying, then it's not really a stake. The whole point of a stake is that you have something at stake in case you misbehave. So there will be punishments in two forms. First, if other members of the network find that you have misbehaved, then you will lose some money. And second, if the people outside the network find that you misbehave, the entire network loses its value, and therefore you're punished. And because you have staked your token and you cannot take it out, you cannot you cannot front run the loss of the value of the system, because I'm locked into the system, and if the system loses value, I lose my money. So this is economic validation network. That's how all the proof of stakes network work. And proof of work are slightly different because people stake basically their mining capacity. Like I have like $1 million worth of Bitcoin mining equipment, and if Bitcoin loses its value, this equipment is worth nothing. But in any case, you have something at stake, and that's what ensures security of the network, proof of stake. As to other uses of the token is also used for accounting within the system, because you have all these people who partake in many sub-consensus and topics, and to ensure that everyone pays their fees in a fair way, all the fee payment is structured in a logically centralized way, but effectively decentralized way. But all the fees are paid in Sky token. So you can't have a topic that says, "Oh, we accept payment in dollars, but we report $0 in Sky token," and then no one, the network doesn't get its fair share. So it's a way to ensure that the accounting is done in the Sky token. It's just like when you pay your taxes. The members of the token basically pay their taxes to the network, and to do that, we do the accounting in the Sky token, which means that all the fees. So the token serves as a utility token in which all the fees for the network are being paid. But that doesn't mean that the end user needs to pay in Sky token, because the end user can change his token the last minute. You want to pay in Cardano, you want to pay in USDT or whatever, no problem. You do a last minute swap between your USDT and Sky token, and then the network receives the payment to the Sky token, and the accounting is in Sky. But you as a user do not have to be inconvenienced, because you could do a last minute swap in the Sky token. So it's really the accounting value and the tax value, and that makes it a utility token if you want.
So allow me to phrase it from a business perspective, to rephrase what you just said. So basically, the token is used to track down every type of transaction data and have a proof that transaction has effectively been processed through our system. It also holds an economic incentive so that people don't basically scam the system by gaming it. And if we were tokenless, that would be more complicated. And the last thing, of course, for the business people who invested in Sky Protocol, this is also a good means to make sure that the system itself has to have its own utility, and it's not possible to directly fork the system and use it, because you would have to also recreate the network. So Sky Protocol is also in this regard a scaling solution that is tied to the effectiveness of its community. Did I rephrase that correctly for the business people?
That's part of it. Yes, I think your topic and my topics have an interest. It's not but yes, in the end, the token you're part of the community by having the token, and then all the accounting and everything. Yes, is done in the token.
Alrighty, and people from the community also asked, okay, so we know that there are other competing scaling solutions on other chains, Eigenlayer, Celestia, and many others. There are also data availability engines that works as data queries. I know you're quite familiar with the systems they have at Tezos and many other competitors as well. On Cardano, we're the only one data availability engine in progress so far, at least the only one that I know of. But there are also other scaling solutions like rollups, for example, and ZK rollups. And some people said, okay, is it possible to use all these scaling solutions at the same time? My short answer is yes, depending on the use case, but I assume your answer is going to be more, well, richer than mine. And the other question is, what's the main difference between these solutions, between rollups and data availability, for example?
Okay, so there is a 2016 or whatever paper called the Plasma paper that explained how to do layer two on. At the time it was for Ethereum, but on any blockchain that has smart contracts, and the design works. But there was a big hole in that paper, which was what if you have what they call a data withholding attack, where the manager of a sidechain refuses to publish the data from the sidechain. So he has it, and his data is correct or is well formed, but no one can see it, and then he can hold the fund hostage. And if there's a way to get money out with the interactive proof, he can basically steal the money from the system. So if you can do a data withholding attack, the thing you can break a layer two. So the layer, the data availability prevents those attacks. And your question was, I forgot. Yes,
Well,
what did you say? Rollups. Okay.
well,
So one way that that you can solve the thing is to have what they call a data availability engine or data availability network or something, and that's what we provide. But in the time that these data availability engines were not available, the Ethereum people invented the principle of rollup, where basically you use the cool data of Ethereum itself as your data availability engine. And so in Ethereum, they found that by using this one-word trick, you could multiply the throughput of Ethereum by 30, basically, by using Ethereum itself as its own data availability engine. And the problem being that in the end, you only improved the data availability by a factor 30. And then Ethereum recently added something like dank sharding, where you can add another factor 10 or 30 or 100, I don't remember, to this thing. But still, it means that your volume is limited by what the blockchain itself can process. You cannot increase indefinitely the scaling, because you're limited by how much data can be published on the blockchain that everyone in the world can see. So in the case of Ethereum, I don't know how much it is, like a 20 kilobytes per second, 100 kilobytes per second, not that much. In the case of Bitcoin, it's 2 kilobytes per second. In the case of Cardano, it's 4 kilobytes per second on average, because Cardano block is like 10 seconds or something. So it's not much. You cannot fit a lot of things. So if you want to do rollup on Cardano, all your data for all your layer twos or etc. has to fit within the 4 kilobyte per second limit of Cardano. So you cannot put a lot of data on a rollup on Cardano. Even on Ethereum, you can put more data, but like 10 times more, 100 times more. Even if it's 1,000 times more, it's not enough to cover all the needs of every application in the world. So rollups, in as much as rollup means use the blockchain itself as your data availability layer, rollups are very limited in bandwidth. It's still better than a direct, it still improves the bandwidth compared to direct transaction on the blockchain, but only so much, not a lot.
So are there pros and cons in using rollups versus data availability, for
The
example?
pros is that yes. The pros of the rollup is that you don't need a new network. So you don't need to widen your trust base. Every time you add a network in your system, now you need to trust a new network. That is, you add a new trust assumption. The network will not be compromised. So if you're paranoid, you trust Cardano and nothing else, rollup is the best you can do if you want. But if you're ready to say, okay, I trust Cardano, but I'm ready to trust another network too, then you can use a DA service. And now you need to trust the DA network to do its job. And that's the trust assumption. But that's why we need to have a solid and trustworthy network to do the DA. You can't just say, hey, you of the three do my DA, but this guy then will be, even if he's competent technically, he can be bought by the bad guys to do a data withholding attack. So you want a trustworthy network to be your DA, and because your DA will be part of your trust base. But if you have a DA in your trust base and your DA can scale, then all your applications can scale. And the goal is that every application that you care about eventually will be decentralized and will have all its data in nodes all over the world that cannot be taken away, that are censorship resistant, that are resistant to failure. If your data center is bound by orcs of the neighboring country, that's okay because there's plenty of redundancy. So as long as the network works as intended, and as long as basically the internet keeps working and service doesn't crumble, your data will be safe.
So that's wonderful. And so one trivial question, is it possible to use rollups and data availability at the same time? And if yes, when is it relevant to do it or not?
So in a way, it's always if you extend the meaning of rollup to mean I'm using some network on which to put the data, then data availability is always a rollup. So in this wider sense of rollup, I'm just offshoring, offloading the data from the main chain. Then yes, it's always rollup. But then the word rollup loses its meaning. The word rollup, strictly speaking, means using the blockchain itself as data availability. And in a way, when you use something else than the blockchain data availability, it's essentially the same design, except that you can actually scale much further than using the blockchain.
So in any case, if you want to scale to tremendous speed, tremendous amount of interactions per second, and the low price of transaction, you need people who, like us, are offloading the main network and offering. Basically, what we're doing is offering space on more space on the blockchain.
So one way I like to think of Sky Protocol is we are a DEX for space, for blockchain space. We want people to be able to buy and sell blockchain space with a caveat that is actually it's actually more like a decentralized. It's not exactly a DEX because it's not. The supply and the demand are not symmetrical in the case of Sky Protocol. The supply of blockchain space is decentralized, but it's offering a centralized, uniform, consensual view to the public. So it's more like the public buys space as an auction, and we manage a decentralized entity, a decentralized but coherent entity that offers space for the blockchain. And the problem is that if you make it a two-sided thing, then the bad guys could take two sides of the same deals, do a self-deal, and cheat and do a data availability attack. The thing to prevent the data availability attack is precisely that you don't allow self-dealing. You only allow dealing with a random set of members of the network, and that's robust. So it's kind of a DEX for blockchain space, but it's not symmetrical. It cannot be symmetrical. And if you wanted to do something symmetrical, you would have to have a way to create trust. And I don't know how to do that. If I knew how to do that, I would do it. The whole point of a network is to create trust, but it's not it's not trust in random people. It's trust precisely in a network that is well established, that has a proof of stake token, such that now it costs a lot to attack the thing. You need to
Yeah, the
to attack.
essence of the blockchain. You trust a protocol that is so
Yeah.
well rigged that rigged towards
Yes.
trust, so that basically the protocol is so well built that even if the person is not benevolent, you don't care. That person cannot do anything to cheat it, so that works.
And that's one reason why we're trying to reuse Ouroboros for our consensus, because it's an algorithm that people in Cardano already trust, or thing that we trust, and we don't want to be reinventing the parts that we are not innovators. I mean, there's no need to innovate on that front when we're already innovating on plenty of fronts, and it's not the thing that we care to innovate on, at least for now. So we want to reuse existing protocol.
Wonderful. All right. And this leads us then, you gave me the perfect transition to talk about the final topic, node distribution models. So you talked a bit about it already, but so we are between Q1 and Q2 2025. Around the testnet, we're going to perform our node sale. So Cardano is very interesting in this regard because you don't have to have top-notch hardware in order to be able to run a node. So Sky Protocol nodes are going, if I'm correct, to require the same level of hardware than a Cardano node. So very affordable, something that you can run on your laptop. But what's the node distribution model? How does it work, and what are the steps if there's some evolution?
Okay, so just one thing. Our nodes will be essentially the same as for Cardano, but compared to the original Cardano network requirements, our network requirements in practice will be like 3 or 4 times those of Cardano. Since you will need to be able to see the Cardano blockchain at 4 kilobytes per second, you will need to be able to see the Sky protocol chain, which will also be 4 kilobytes per second, and you will need to be able to see the topic you're interested in, which is also at least 4 kilobytes per second, and you will need to have extra traffic. So basically, you will need like 4 times the bandwidth, the minimum bandwidth of Cardano to run your node. But it's still pretty low, and the bandwidth required for Cardano hasn't increased in many years. So we believe that it's still pretty cheap, very cheap to start a node for Sky. And then the question is, how do we do our initial node distribution? Well, we want to start with the proof of authority network, just because it's a lot of work to do proof of stake and do it correctly, and we want to start our network as soon as possible and offer service as soon as possible. So we'll start our service as proof of authority, and there's will be plenty of things to debug and to ensure it's correct as we launch as proof of authority. And later, within a year, hopefully, we can replace the proof of authority with proof of stake. And so for this proof of authority, we're doing an initial node sale. We will be doing an initial node sale, so you can be a node and be an early adopter and hopefully earn early fees on the network. But even if not, gain experience, help us gain the experience of running the network and earn some tokens that, so your proof of authority token will be at some point translated into actual proof of stake tokens for where we launch as we actually launch a network as proof of stake later, relaunch a network as proof of stake, or do a network upgrade to from proof of authority to proof of stake.
Is it how connected are the testnet and the first node sale? Are they going to theoretically happen at the same time or within the same time frame, but not exactly at the same time?
So we'll first launch a centralized testnet, then a testnet that is a proof of authority where we're the only authority. Then we will do the node sale, and then the members of the node, the winner of the node sale, the buyers, the new members, the node operators will be the new operators for the proof of authority network. And then we will do a network upgrade to proof of stake. And then hopefully the same and or more people will be node operators. Also, because we want to do delegation, even when we have proof of stake, we need to have an existing pool of operators ready to operate the network. So anyone can join the network and operate it, but uh, we need to have an existing pool of operators before we do the proof of stake.
So centralized testnet, decentralized testnet, node sale, mainnet, and then switch to proof of stake.
Yes, yes.
All right. Thank you so much, Fare. That was a blast. And since we already reached half an hour, I think I'm going to release another video of the huge code updates we have to share, which actually we're
Okay.
going to shoot right now, but which is going to be released the next day, the day after the video you guys are watching. So yes, I'm sorry, I'm a horrible person for teasing you guys. Now let's record a new video for the others. Follow us on X, formerly Twitter, on our Discord, and as usual, if you have any question, hit us up on the social media. We always respond. We also respond on LinkedIn, even though at the moment LinkedIn is pretty much useless for people in the Cardano ecosystem outside of the very thin B2B world. So Discord and Twitter, feel free to send us messages in any language. We will be happy to answer. Cheers, everyone.